Welcome to the lecture 3 of this Python programming course. Today we'll discuss about data types. We will talk about typecasting. We'll also go through the topic of reserved keywords. So let's get started. So the idea of reserved keywords is nothing but, the reserved keywords are nothing but the predefined keywords. These are the predefined keywords that already exist in the Python programming language. Okay, whenever the creators of Python created the language, they gave us some predefined words so that we can use them for our own functionality. So each and every keyword has their own functionality and meaning in Python. Each word have their own functionality and meaning. For example, if I take a keyword called fur, this is nothing but a keyword in Python. This keyword will provide us a functionality to create a loop. Okay, if I want to print a statement like this, print a statement hello, then if I want to print it once, then I'll write this code. But if I want to print it 100 times, then I'm not going to write this code 100 times. Okay, like writing the same line 100 times is it's nothing but duplicacy and redundancy. So instead of that, I'm going to use this keyword to create a loop so that this statement will get printed 100 times. So this keyword has its own functionality. What's the functionality? To create a loop. To create a loop. In the similar manner, we have another keyword called if for the flow control idea, and we have so many other functionalities like try, catch. So each and every keyword, each and every reserved word has their own functionality and meaning. And using this functionality, we will write programs. Okay, we are going to use these functionalities in our program so that it will become easy for us. Okay, the reserved keywords are already, they already exist in the Python libraries. The Python creators provided these keywords to us so that we can use these functionalities in our programs. So in Python, some words are reserved to represent some meaning or functionality. Okay, each and every keyword represents a functionality or a meaning. Such types of words are called reserved words. So there are in total 33 keywords in Python. So these are the 33 keywords here: true, false, none, or, not, is, if, elif, else. So all these keywords provided here are the reserved keywords in Python. We are not going to discuss all these keywords now because learning all the keywords, all the reserved words is nothing but learning Python programming language. Okay, because if I talk about if, elif, else, while, for, break, continue, all this comes under the flow control topic. And if I talk about try, except, finally, these comes under the exception handling concept. So learning each and every keyword is nothing but learning Python programming language. For example, if I take import, this is used to import a module. As is used for aliasing, and class is nothing but defining a type. We'll discuss classes in object oriented programming. Def is used to create a function. So each and every keyword here, these keywords are used for different purposes at different places that we will discuss one by one. Okay, we'll learn one by one. That's the whole concept of this Python programming language. So all reserved words in Python contain only alphabet symbols. This is a point to be noted. If we look at here, in any keyword, we couldn't find any number. All these keywords are alphabets. Okay, I mean we created these keywords only using alphabets. We haven't used any numbers. That's one point to be noted. And the other point to be noted is that except these three keywords, okay, except true, one second, except true, false, and none, all the other keywords contains only lowercase alphabets. Okay, lowercase alphabet. Here I have T, I have F here, and these three are uppercase. But other than these three keywords, all the other keywords are lowercase letters. So using this code, I can list out the keywords in Python program. In a Python program, if you want to list the keywords, you can use this piece of code. Let's try it in the Jupyter notebook. Okay, let's try to import it. Import keyword. What we are doing is that we are importing the module. Okay, we are importing the keyword module. Keyword is a module. Module is nothing but a file. Inside the file we write the whole code. So we are importing the keyword module, and then using this module I'm going to run this kv list, I mean keywords list. Then I'll get all the 33 keywords here. Okay, in the format of list. Each keyword is separated by a comma, and this is the list of keywords. Okay, 33 keywords. You can count it down. You will have 33 keywords here. So now we'll talk about data types now. Okay, I think I've already discussed about type and object in our previous lecture. So, let's recall it again. So the concept of type, uh, mm, so the concept of type and object that we already discussed this in the previous lecture. So type is nothing but the virtual concept. Okay, it's like the virtual imagination, or I can say virtual imagination concept. Object is nothing but real life entity. For example, if we consider the concept of humans, then humans is nothing but a concept. Okay, humans, everyone are humans. We all are humans. It's a concept. Okay, it's a virtual concept, but we are real life objects. I mean, we are real life persons. We are people. We have the physical existence, but the concept of human doesn't have any physical existence here. So I can say that. Type is nothing but it doesn't have any physical existence, but it's like a concept which doesn't have any physical existence. But object has real life, it has physical existence. So here I can say human is a virtual imagination which is called type, and the objects are nothing but me and you, like all the people living on the planet. So all these people are objects, and this is nothing but the concept of type. Okay, the virtual imagination which doesn't have any physical existence, but it's just a concept. Okay, at the same time, if I talk about integers are nothing but a group of numbers from infinity to, I mean, minus infinity to plus infinity. We have 0, 1, 2, 3, 4, so on until infinity, and we have -1, we have -2, so on until minus infinity, and here until plus infinity. So the integer is called the type because we grouped similar type of objects here, because everyone, like all of the objects here are nothing but the integers, so we group them together. So that's called type. And the real life entities, okay, 0, 1, 2, these are called the objects. So we can say that type is nothing but grouping similar kind of objects. Okay, for example, in universities, in schools, we group people together, we group students together into a class. In 10th class we have all the students studying in the 10th standard. In 9th class we have students related to the 9th standard. These are nothing but the similar, they have the similar attributes. Everyone has the same subjects, they have same courses, they will have same examinations. That's the reason we group them together into the concept of class. We'll talk about class in the object oriented programming. Class and type are similar to each other. Okay, they are the same. So type is nothing but grouping similar kind of objects here, and it's like the concept, and the object is the real life entities. So the same concept we can apply it for the data. Okay, if we group similar kinds of data, then it's called a data type. If I group integer type from minus infinity to plus infinity, then it is the integer type data. If I group floating point data like 2.3, 5.3, anything which have decimal point 6.5, if I group them together, then it's called floating point data type. And if I group complex a plus bj in the form of whatever the number, if it's in the form of a plus bj, then it's called complex number. 3 plus 3j, 5 plus 8j, If we group these numbers together, then it's called the complex data type. And if I group true and false, which we use in digital logic, if I group these two values, then it's called Boolean type. Okay. So grouping similar kind of objects is nothing but the concept of type. So data type represents the type of data present inside a variable. In Python, we are not required to specify the type explicitly. So let's try to create a variable here. So a is equal to 10. I'm just trying to create a normal variable here on nothing fancy. So a is equal to 10. And if you can see that I haven't included any data type here, like I haven't mentioned the data type like this, like integer or float. I haven't mentioned anything. I just mentioned a is equal to 10. I just mentioned the variable name, and then I linked it to the object 10. So that's what happens. So let's try to print it. Print a. So I got the output as 10. So whenever I create a variable like this, you all know that we discussed in a previous lecture. Inside the stack, the variable is created and it will point to the object inside the heap. So the object is created in the heap. The object is created in the heap. And inside this one, at the same time, if I create a different object, 1000, this will point to the object 1000 here. So we are not actually mentioning any data type to this A. We are not mentioning any data type to this B. For example, in C language, what we do is that we will mention the data type for the variable. Okay, we will do something like this. For every variable, we should include the data type. If we don't include the data type in C, then we'll get a compile time error. But in Python, that's not the case. We don't need to include any data type for this variable because the type is not actually related to this variable. The type is related to this object. Okay, we will discuss this concept in very detail in the next lecture. But as of now, just understand that we don't mention data type for the variable. We just declare the variable as it is. We don't mention anything during the runtime. Okay, when the program is getting executed, I mean, for example, if I open WhatsApp in my phone, then the WhatsApp will be transferred into the main memory and each instruction will get executed one by one. So during the execution, the type of the data will be attached to this object. Okay, like in the previous lecture, we saw that each and every object is declared as the Py object. Inside this Py object, I have type, reference count, and value. So here the type is like during the runtime, this object is created. Inside the object, during the runtime, like the 10 is nothing but the integer. The type will be assigned to this object. The type is not getting assigned to the variable. Okay, it's getting assigned to the object here. The value is 10 and the reference count is 1 because only one variable is referencing to this object here. If you can see that only one variable is referencing to this object, so that's the reason the reference count is 1. We will discuss about this in detail in the next lecture. So but now just understand that we don't mention data type to the variables in Python. That's the reason we call Python as dynamically typed language, because the type of data is assigned during the runtime. That's the reason we call Python as dynamically typed programming language. So these are the data types in Python: integer, float, complex, boolean, string, bytes, byte array, range, list, tuple, set, frozen set, dict, none. In this lecture, we are going to discuss these 5 data types here. These are called the fundamental data types, and in the next in the upcoming lectures, we will discuss all the remaining data types. I'm also going to make a separate sessions for list, tuple, set, dictionary, because these are very important. In Python, we are going to do a lot of problems based on these data structures. We'll also use these structures in object-oriented programming. But that's the reason I'm going to dedicate separate sessions for these data structures. In this lecture, we are going to focus on this fundamental data types. Okay, integer, float, complex, boolean, string. All these things are called the fundamental data types. So we'll start a discussion with integer data type. We all know that integers are nothing but infinity to minus infinity. So all the positive numbers and negative numbers comes under the integer type. So we have -1, we have -2, we have -3. All the integers, okay, all both the positive numbers and the negative numbers without the decimal point is nothing but the integer. Okay, we can use int data type to represent whole numbers, which means integral values. The int data type in Python is used to represent whole numbers, both positive and negative, without any decimal point. If you have any decimal point, this is not in data type. Okay, we should not have any decimal point. Okay, 4 is an integer, 100 is an integer, 1000 is an integer, 2085, 2856 is an integer. All these an integer because it doesn't have any decimal point. If you have any decimal point, that's not integer data type. Okay, in Python 2 we used to have a data type called long data type because in Python 2 to represent long integers like this, if I want to represent these large integers, then I can't do it using the integer data type. I should use long data type in Python 2. But in Python 3, they deleted this long data type. Now we can use integer data type to represent any integer. Okay, any integer, there is no limit for that. As long as your memory is available, you can declare any large number of integer. Okay, any large number, there is no restriction for this one. But in Python 2 we used to have two data types, integer and long, but right now we are using Python 3. We only focus on this one, int. There is no long data type in Python 3. These are the two methods. I mean, we have so many methods in the integer type, but these two are the somewhat important methods. As integer ratio returns a list of the numerator and the denominator. If I have integer 2, it returns the numerator 2 and the denominator 1, because 2 is nothing but 2 by 1, 3 is nothing but 3 by 1. So if I have 2, then this function will return 2 and 1. If I have 3, it will return 3 1, because 3 is nothing but the numerator and 1 is the denominator. And the bit count function, what it will do is that it will first convert this decimal form into binary form, and then it will return the number of ones in that binary form. Okay, we'll see this we'll see these functions in practical here. So first I'm going to declare a variable. Let's declare a 22. Let's try to print it. So we got the output here. So first let's try to check the type. Let's try to check the type here. Type of B is nothing but integer, int. Let's try to print this type. When we print it, we are actually printing the class. Okay, so here we are printing the class. Class is nothing but the type. Okay, we all know that in our universities we have classes. In every class, like all the students who are studying the same courses or who are taking same classes are combined into a single class, and we call that as 10th class, 9th class, because we group all the students who are taking same type of courses. Okay, they have some similarities between each other, which is the reason we group them together. Okay, we'll talk about class later in the object oriented programming, but class is nothing but the type. So I can also print the address here, address of this object using the id. Address of B is this one. Okay, let's write it down here. So we have a function called type. Used to return the type of the object. Okay, if I declare a is equal to 10, then type of a returns int. If I declare a floating point variable is nothing but it's a number with a decimal point. Okay, it's a number with a decimal point. If you have a decimal point, then it's nothing but the floating type. So type of B is nothing but float. So this is the function of this is the meaning of type function. And we have another function called id function. Id function returns the address of the object. Okay, if we try to print the address of the A, we'll get some number. Okay, we'll get some number here like 4 5 6 7 8 2 3 1, some number here. So we can represent integer values in the following ways. We can represent the integer values in decimal form, that we already know, like we use decimal form every each and every day, like 10 100 23. This is nothing but the decimal form. We have binary form. Binary form is nothing but zeros and ones. Octal form is the number which can be represented with the values 0 to 7. Hexadecimal form, it's like 0 to 16. And first we will start with 0 and we'll go until 9, and then from 10 we will start representing with A B C D E F. Okay, 10 11 12 13 14 15. Okay, so first we'll talk about decimal form. Decimal form is nothing but the base 10. Okay, so whenever I talk about base R, the allowed digits in this base are from 0 to r minus 1. So if I have base 10, then the allowed digits are 0 to 9. 10 minus 1 is 9. If I talk about base 2, then the allowed digits are 0 to 1. 2 minus 1, 2 minus 1 is 1. If I talk about base 5, then the allowed digits are 0 to 4. So at the same time, if I talk about base 10, the allowed digits are 0 to 9. It is a default number system in Python. Like whatever we declare in Python, the PVM will store it in the decimal format. Example, A is equal to 10. This 10 is nothing but the decimal form, because the allowed digits are from 0 to 9. You know, like 0 1, 0 2, 0 3, 0 4, 0 5, 0 6, 0 7, 0 8, 0 9, and then we'll start with 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 0, and then we'll start with 21 here, 22, 23, so on. Okay, like whatever number you take, the allowed digits are from 0 to 9. Okay, even if I take 2 8 9 6, we only take from 0 to 9. Okay, we will not use any other digit. Okay, the main digits that we use in decimal form are 0 to 9. And we can also represent the integer values using binary form, which is nothing but the base 2. The allowed digits are zeros and ones. So something like this. Okay, if I want to declare a variable, and if I want to represent it using the binary form, then I can write something like this. But before writing this, I need to prefix this number with 0b, or I can also prefix with 0 capital B. Okay, 1 1 1, 1 1 0 0. This is the prefix, and this is the value. So to represent the variable, I mean to create a variable using the binary form, then I should prefix it with 0b or 0 capital B for the binary form. So these are the examples. You can see that here 0b 1111, and then 0b 123. Do you think, is this valid? Do you think this one is valid? No, it's not valid, because we are also using 3 and 2, but the allowed digits are only 0 and 1 in binary format. So this is valid, this is invalid. And what about the third one, B111? We are only using the digit 1, but we are not actually prefixing with 0b. We are just prefixing with B, so this is invalid. Okay, so the next form is octal form. We can also represent the integer values using octal form. The allowed digits are 0 to 7, because it's base 8. Octal form, octal means 8. The allowed digits are 0 to 7. So whatever number you define, it should be, the digit should be 0 to 7. You cannot put 8 here. Okay, for example, if I take here, if I'm trying to put 8 here, So this is invalid, this is valid, because 1 2 3 is in between the range of 0 to 7. So to define a octal form, we need to prefix with 0 o or 0 capital O. Here I defined with 0 small lowercase o. Here also I prefixed with 0 lowercase o, but here I'm using 8, so that's the reason this is invalid. In the octal form, we can only use the digits from 0 to 7. And this is the hexadecimal form, which is nothing but the base 16. So what are the allowed digits here? 16 minus 1, 15. So 0 to 15 are the allowed digits. As I said before, we won't represent 10, 11, 12, 13, 14 here. We represent them with the alphabets here. So first we'll represent 0 to 9, and from 10 we'll represent A to F. I'll write all the digits here: 0, 1, 2, 3, 4. Until 9 we are going to use digits. From 10 we are going to use A or capital A. We can also use capital A here. We can either use small b or we can use capital B. We can use small c, lowercase c, or capital C until F. Until F or capital F. We can either use lowercase f or we can either use capital F. Okay. The value should be prefixed with 0x or 0 capital X. Like, for example, if I took FACE, this 0x is nothing but the prefix. This is the value here. This is the prefix and this is the value. So now let's check it if this valid or not. F is allowed digit, A is allowed digit, C is also allowed digit, E is also allowed digit. So this is completely valid. But look at here, R is not valid because, like A, B, C, D, E, F, we are only allowing these alphabets. So R is not allowed in digit. So that's the reason this is invalid. So being a programmer, we can specify values in any format. Okay, we can specify either using decimal, we can specify using binary, we can specify using octal, we can also specify using hexadecimal. But the PVM will always provide values in decimal form. Okay, let's try to look at all the examples for these forms here. So first, let's again define an integer here. Let's try to print it. Okay, let's take a different number this time. Let's try to print P. So now this is the decimal form. Because the allowed digits are 0 to 9. This is decimal form. I'll try to zoom it. I hope you can see it now. You can see it more clearly. Okay, let's try to. B is equal to, what's the other form? It's binary form. We need to prefix using 0b, 1 1 1 1 9, oh sorry, 0 0 0. Let's print it. Here we go. Here, the same concept, the same logic I discussed here. Being a programmer, we can specify the values in any form, but the PVM, the Python will only provide it in the decimal form. That's what I try to show you here. Here I'm specifying using binary form, but whenever it's showing the output, it's showing in the decimal format. Okay, this is not binary format. Let's try to change it here. Okay, 998. So I defined this variable. I created this variable using the binary form, but whenever the Python is giving the output to the user, it's only showing the decimal form. We can represent, we can give the Python in any format. We can give the input in any format, but it will give the output in only decimal form. Let's try to define another variable in octal form. For octal form, we need to prefix 0 and small or capital O, anything is okay. 564, this is octal form. Print C. So let's look at it. This one, 3371 is decimal form, but here we declared it with octal form. This is octal form, but when I try to print the output, it's in the decimal form. Okay, but I defined this variable using the octal form. Let's try this one. in the hexadecimal form. For the hexadecimal form, we need to prefix with 0. We can either use capital X, we can also use lowercase x. So let's try to use this one and then print D. So I try to define the value using hexadecimal form, but when I try to print the value, the output is in the decimal form. So these are the 4 forms that I can use to represent integer variables, sorry, integer objects. I can either give the input using decimal form, I can give the input in the binary form, I can give the input in the octal form, I can give the input in the hexadecimal form. In these 4 forms, I can give the input using, I can create variables using any form, but the output will be provided only in the decimal form. Okay. So we have some functions for the base conversions. This is the bin function. This is the oct function. This is the hex function. So bin function is used to convert from any base to binary phase. So if I have octal here, from this form I can convert it into the binary form. If I have hexadecimal form, I can convert it into the binary form. If I have anything in decimal form, then I can convert it into the binary form. The same goes with octal. If I want to convert binary to octal, then I can use octal. If I want to convert hexadecimal to octal, then I can use oct function. If I want to convert decimal to octal form, then I can use this oct. And the same goes with the hex. We can use hex to convert from any base to hexadecimal. Let's try to understand this using some examples. Let's create a random number. First we'll try to print this number, and then we'll try to convert it into the binary form now. Okay, we are learning first binary function. So let's try to convert it into the binary form. Print, we'll use the bin function. Inside the bin function, we'll pass the input. Okay, we'll pass the number here. We created the number variable. We assigned it to the 555 object, and we are passing this object. We are passing this variable in this function. And now when we print it, we'll get the binary form for this number. And let's create something. Oct value is equal to 0.0564. Let's try to print it. We all know that whenever the output is given, it's given in the decimal form. But let's try to convert this oct value into binary form. Print bin, we are going to pass this oct value here. So now, this value got converted into the binary form. The same goes with the hex value. Let's create a variable hex value. 0x, let's use the same example, face. Let's try to print hex value. So this is the hex value. Like we all know that the output is shown in the decimal form. Now let's try to convert this hex value into binary format. Hex value. So this the hex value is converted into the binary format. So bin function, it's used to convert any type into binary form. Any form into binary form, if you want to convert it, we will use the bin function. The same goes with the oct function. The same, the same idea is for the oct function. Let's try to define, let's create a bin value here. Bin value, we need to prefix with 0b for bin, 0 for oct, 0x for hexadecimal. So this is the bin value. I'm printing it. It's printed in the decimal form. Now let's convert all these numbers into octal form. So I'm going to use oct function here. print oct, okay, hex value, print oct, bin value. So first the decimal is converted into octal form 01053. The hex value is also converted into octal form, and the bin value is also converted into the octal form. So to convert any form into octal form, we use oct function. So the same goes with binary bin function. To convert from any form to if we want to convert any form into binary form, we will use bin function. And let's look at the hex function too. The definition is same. To convert any form into hexadecimal form, we'll use the hex function. Let's try to convert the decimal form into hexadecimal format. This is the decimal format, and then print, use the hex function. We'll try to convert the bin value, and then we'll try to convert the oct value into hexadecimal form, hex, and inside this we'll convert the oct value. So here we go. So these three are the outputs for this last three statements. First, we converted decimal format into this hexadecimal form. We then converted this binary form into hexadecimal form. Then we converted the octal form into hexadecimal form. So these are the functions. Okay, these are the functions used to convert from one form to the other form that we use for the integer type. Yeah. So that is all about the integer type. We saw how many forms we can represent the integer type. We saw the type we saw the functions which are used to convert from one form to another form. So that's all about the integer type. Let's get into the float type here. So the meaning of float is nothing but a number with a decimal point. If I have a number and with a decimal point, then it's called float. It's called the floating point variable. So sorry, floating point object. 3.5, we have a decimal point here, then it's float. 33.53, we have a decimal point, that it's float. Okay, whenever you see a decimal point, then it's nothing but float. So we can use float data type to represent floating point values, which is nothing but decimal values. Here we go. This is an example 1.234. We have a point here. So let's try to print the type, and we got float. So let's try to represent this. Float value 3.444, print. Here we go, class float. Let's try to print type like directly. Here we go. We got float, and when we try to print the type, then we got the class here. So we can also, this is how we represent floating point value. Okay, we need to put a point, we need to represent the decimal, and all the decimal numbers, all the decimal, whatever the number, if you have any decimal point, then it's considered as a floating point data type. We can also represent this floating point data type using exponential form. We all know about exponential form. Whenever number is very large, then we can reduce it using the exponential form. I'll try to show it here. Float exp. For example, if I have a number like this, okay, instead of saving like this, what I can do is that I can simply put e, and I can put 8 here. I'll tell you the example in a bit. I'll tell you the meaning of this in a bit. Let's try to print this one, float exp. Here we go. I'll also try to create another one, float negative is equal to, let's take 5.6. Let's take capital E this time. We can either use small e or capital E, minus 7. Let's try to print it. Float negative. Yeah. Or I can use something like this. Yeah. So the meaning of exponential form is that, okay, if whenever I have a large number like 4, 5, so many zeros, so instead of writing this large number, I can simply use this e format. This is nothing but exponential format, exponential form. This is nothing but 4.5 into 10 power 8. This one we have, we have like 8 zeros here, and this is nothing but 5.6 into 10 power minus 7. That's the reason I used minus symbol here. This is the minus symbol. I used minus symbol here to represent this one. So what happens here is that for 4.5, first I'm going to put 8 zeros here, and then I'm going to put like transform this point up to 8 decimal points. 1, 2, 3, 4, 5, 6, 7, 8. So we'll get point here. So 45, 0, 0, 0, 0, 0, 0, 0, 0.0. So that's what we got here. So in the end, we got this 0.0. So the same goes with this one, 5.6 into, I'm sorry, 10 power minus 7. So what happens here is that first I'm going to put zeros to the left side because it's 10 power minus 7. So I'm going to put zeros to the left side, 1, 2, 3, 4, 5, 6, 7. Then I'm going to put this decimal point for 7 times. I'm going to change the decimal points, 2, 3, 4, 5, 6, 7. So we'll get here. So 0, 0, 0, 5, 6, 0.56. The representation is a bit different here because it's directly representing 10 power minus 7, but this is the basic idea. Okay, whenever I have 10 power 8, then I'm going to put zeros to the right side, and then I'm going to shift this decimal point to the right side. If I have 10 power minus 7, then I'm going to move the decimal point to the left side. So we can also represent floating point values by using exponential form using scientific notation. So this is nothing but 0.4 into 10 power 7. This is nothing but 4.2 into 10 power minus 4. We saw the meaning of these two statements. So the main advantage of exponential form is that we can represent big values in less memory. Okay, I'm not going to write I'm not going to write all these numbers like this. So instead of just writing all this like this, I'm just going to use a scientific notation. So this is applicable for the float data type. And we have a note here, we can represent integer values in decimal, binary, octal, and hexadecimal, but we can represent float values only by using decimal form. So we cannot represent float type with binary, octal, or hexadecimal. We can only represent the float type using the decimal format. So if I try to do something like this, okay, this is nothing but octal form. We are using prefix 0 small lowercase o. This is the prefix. So this we are getting a syntax error, invalid syntax. So we can only represent float values by using decimal form. So then we'll start with complex data type. anything, okay, any number which is in the form of a plus bj is nothing but a complex number. We use complex numbers in mathematics, usually in programming, while designing websites or while designing applications. We don't usually use complex numbers, but these complex numbers are used in data analysis and for statisticians and for mathematicians. So Python, we all know that Python gives a lot of support to this mathematicians, statisticians. So that's the reason we have this dedicated data type for the complex number. Any number which is in the form of a plus bj is called as a complex number. For example, 2 plus 5j, it's a complex number. 5 plus 3j, it's a complex number. So a complex number is of the form a plus bj. A and B can contain integers or floating point values. We can either put, we can either put integers here, we can either put floating, anything is fine. So A plus bj, A is nothing but the real part, B is the imaginary part. So in the real part for this A, okay, in this A, so for this real part, if I want to use the integer value, I can represent this in real part with either integer or float. But if I am going to use integer value, then we can specify this real part using decimal form. We can specify with octal form, we can specify with binary form, or we can specify with hexadecimal form. But imaginary part should only be specified using the decimal form. Okay, here you can see that the real part I'm going to represent using the binary form, then that's completely okay. But for the imaginary part, I should only represent with the decimal form. Let's try to look at an example and we'll understand it in a better way. So let's try to define a number, complex number 2 plus 5j. Let's try to print it. Print complex number. We got the output 2 plus 5j. Let's try to print the type. So the type of the complex number will be complex, the class complex. So we have the class complex. So here we discussed that this is the real part. Okay, the 2 is called the real part and the 5 is called the imaginary part. So I can either use float here. So if I can 2.6, then we'll get 2.6 here. So whenever I do 5.7 here, we'll get 5.7. We can either represent it with the integer format or we can represent with the float format. But for the real part, if I want to use integer type, then I can use this binary form too. I can represent the integer form in the binary form too, like 111. That's completely okay. I think a plus 5. What happened here? Complex number 0b. Okay, this is O. So here we go. So I can represent it in the binary form, I can represent it in the octal form. Let's try the octal form too. 0 O 5 6 7 0 O. So that's completely okay. I can also represent it in the hexadecimal form. That's completely all right, because it's the real part. The real part can be represented in any format. It can be represented in the decimal form, it can be represented using binary form, it can be represented using the hexadecimal form, it can be represented with the binary form. But when we talk about the imaginary part, we can only represent with the decimal form. Yes, we can represent with the float point, but if you're going to use the integer type, then we can only use decimal form. If I try to use binary here, let's put 0 here instead of O, then we'll get an error, invalid binary literal, because for the imaginary part we can only use decimal form if you are using the integer type. That's what I want to show here. So if we use int value, then we can specify that either by decimal, octal, binary, or hexadecimal. But imaginary part should be specified only by using decimal form. That's the main point I want to make you understand here. So the complex data type has inbuilt attributes to retrieve the real part and the imaginary part. We know that if I have 2 plus 3j, 2 is real part, this 3 is imaginary part. So I declared it, I declared the variable here, I declared the variable c. Now this c is pointing to this object 3.6a. So whenever I use the real variable, then I'll get the real part. If I use imag, then I'll get the imag part, imaginary part. Let's try to let's take any number, okay? 3 plus 6j. Yeah, now let's try to print complex. Let's try to print complex number dot real. I'll get 5 now. We got 5. If I print complex number dot imag, then I'll get 6. I got 6 here. We also have it. We also have another function called conjugate function. This function is used to change the sign before the imaginary part. So here 5 plus 6, before the imaginary part I have plus symbol. Now if I use the conjugate function, then it will be changed into the minus symbol. Print, okay, let's complex number dot conjugate. Let's try to print this complex number again. Why did we get 5 plus 6j here? Conjugate is the spelling right? Conjugate. So if you can see here, first I declare 5 plus 6j. So when I try to print the conjugate, conjugate is nothing but changing the sign, okay? When I try to print the conjugate of this complex number, then this symbol has changed from plus to minus, and we got 5 minus 6j. So you know, we have a conjugate function which can change the sign of the complex number. So then we'll discuss the bool data type here. Bool is nothing but the boolean data type. This boolean data type has only 2 values here. Inside this bool, we only have 2 values. One is true and the other one is false. True is internally represented as 1 and false is internally represented as 0. So we can use this data type to represent boolean values. The only allowed values for this data type are true and false. Internally, Python represents true as 1 and false as 0. If I want to create b is equal to false, then I can create a variable like this, and internally this false is stored as 0 and this true is stored as 1. So you know, I declared b is equal to true, type of b is boolean type, and I'll try to show this in the program. Let's get into the program and then we will try to boolean type. True, type of we'll get bool here. Then if I try to print boolean type, then I'll get true here because the value the object we gave is true here. But internally, internally it's stored as 1. How can I prove that? I can print true plus 2, then I'll get 2 because true is 1 and true is 1, 1 plus 1 is equal to 2, because internally the Python stores this true and false as 1 and 0. If I try to print false plus 2, then the answer would be 1. Then the answer would be 1. So internally true is represented as 1 and false is represented as 0. So that's how the Python internally represents the Boolean type values. So then we'll start with the string data type. So the meaning of string is nothing but sequence of characters. Okay, if I want to represent a sequence of characters like ABC, then this is a string. Then I can write my name here. This is a string. I can write India. This is a string because these are sequence of characters. This is a character. 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 The sequence of characters is nothing but a string. To represent the text data, okay, to represent the text, we create, Python provided a data type called string data type. It represents the sequence of characters. So a string is a sequence of characters enclosed within a single quotes or double quotes. So whenever I'm trying to declare a variable with string, then I need to use either single quotes like this or I can use double quotes like this. Either one is okay. So if I want to name is equal to, I can either use single quotes. I can also use name1 is equal to, I can also use double quotes. Either one is okay. So we can, the sequence of characters could be anything. Okay, it could be letters, it could be special characters too, it could be spaces too. Space is also considered as a string. It is also considered as a character. And we can also represent digits as a string. Something like this 10, because we enclosed it in a double string. The 10 is string now, it's not integer because we enclosed this 10 into with the double quoted integer, with the double quote character. If I do something like this, then this is string. If I do something like this is string. So by using single quote and double quotes, we cannot use this multi-line strings. For this requirement, we should go for triple quotes so that we can represent the multi-line strings. I'll show it in the program. String value is equal to anything here. So the output is mono here. Let's try to declare anything. Name is equal to, using double quotes now. So we can also define using double quotes. We can also declare using single quotes. Now let's try to define name1 is equal to like this. First we will try to use single quotes. So I tried to define a string in multiple lines, but if you can see here, this one is in a different color, this one is in the black color. It means that we are going to get an error here. Okay, let's try to print this and see what error we will get. Name1. So what happened here is that the string started here and it never ended. We never ended the string here. The Python is expecting us to, it's expecting to end the string here. If I enclose it here, then the string is we end the string, but I'm not actually ending the string. So that's the reason the Python is expecting this character here. So that's the reason the syntax error is unterminated string literal, because we didn't terminate the string literal. We haven't put we tried to put it here, but the Python is expecting us to put it here. So for this requirement, we need to use triple quotes here. Let's try to copy this one and paste it in between this. Mm, why are we having 4 here? Yeah. So now I'll not get it. I'll not get any error because even though I'm using the string in multi lines, then I will not get error because I'm using triple string here. So this is how I'll get the output. I can also use double quotes 3 times. Let's copy this in between the string. Did we have 4 or did we? Okay, let's delete 1 and so now let's try to print it. Unterminated. Okay, we have 4 here. Okay. So we can either use single quote, I mean triple quote using the single character, I mean single quote. We can also use double quotes 3 times so that we can define the strings in multi-line. So this is the basic idea here. And in this lecture, I'm just going to give you a glance on like we are just going to, you know, learn the basics of strings. But in the upcoming lectures, I'll take separate sessions of string handling, and we will talk a lot about string handling. We'll talk a lot about strings. We'll understand each and every method that we can use on these strings. But in this lecture, we'll just understand the basics because this lecture is about the data types. We'll just understand the basic data types, the basic definition of these data types, and but in the future, like after like 3 to 4 lectures, I'll talk about strings in very detailed manner. We'll talk a lot about the methods of strings. We'll try to understand strings in very depth. We'll also do some problems on the strings. So with strings, we can do 2 things. We can either concatenate. Concatenate is nothing but adding 2 strings. Adding 2 strings. Repeat strings is nothing but repeating the string. If I have ABC here, I can repeat it two times. I can repeat it 3 times like this. ABC, ABC, ABC. So first of all, I created a string like this. A is equal to my, B is equal to self. Then I try to concatenate this. A is nothing but my, B is nothing but self. And if I concatenate this, then I'll get the output myself. So then I try to I try to repeat the string my here. I'm trying to repeat it 3 times, then I'll get output like this. My. We'll talk about this in the upcoming lectures too. We'll work on strings a lot. So like just right now, just understand the basics of string, then we will talk in very depth in the future lectures. We have a function called len, which can give us the length of the string. So if I create a string like this, ABC, so what's the length of this string? We have 3 characters here. So the length function will return 3 here. So len is a function used to retrieve the length of the string in the parentheses. So these are the parentheses. Inside the parentheses, the number of characters we have that we will return using the len function. Okay. So here s is equal to ABC evaluates to 3 because we have 3 characters inside it. So in strings, we use the concept of indexing in strings, just like in the arrays in C language. Arrays concept in C language use the concept of indexing. In the similar manner, even for the strings, we use the concept of indexing here. For example, if I have ABC here, this ABC is stored like this: A, B, C. And the index started with 0. We have 0 here, 1 here, 2 here, then -1 here, -2, -3. So Python string supports both negative indexing and positive indexing. So I created a ABC here. This is how we stored string. I mean, this is how Python stores string in the memory. So using the concept of index, I can retrieve the characters here. So using this one is the name, and by using the index 0, I can retrieve the character. S of 0 is A, S of 1 is B. This is we got. S of 2 is C, and S of 3 is error because we don't have any. Okay, I need to put square brackets here. We don't have any index here. We don't have any index 3 here. So that's the reason we got the error. We can also retrieve the characters using the negative indexing. -1 retrieves C, -2 retrieves B here. So that's the concept of indexing in strings. We'll talk about indexing in very detailed in the upcoming lectures. We can also slice a string. Slicing is nothing but cutting a string. Okay, for example, if you have a pizza, if you slice it into two parts, then this is one part, this is two part. At the same time, if I'm going to slice this string into two parts, this is one substring, this is another substring. So what we can do to slice a string? First, I need to mention the starting index, then I need to mention the stop index, then I need to mention the step. Step is nothing but the increment. First, I can mention the starting index. I can either mention I can mention 1 here. Let's take a bigger string here, A, B, C, 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 C. So let's so 0, 1. So what I can do here, maybe I will, using n, I'm representing this. So n of, first I need to mention the starting index. So I can either mention, let's take 2 here. First I need to mention the starting index. I'm going to mention 2 here. Then I'll put this colon. Then I'm going to mention the stop index. I want to mention 5. And then I'll mention the step. So what happens here is that from 2, so from this string from 2 until 5, but in strings slicing, we'll only get 2 to 4. We will get stop -1. Okay, whatever index we mention here, from starting index to stop -1, stop is 5 and stop -1 is 4. So until here we'll get the string. So we'll get 2, we'll get 3, we'll get 4. So we'll get CCC as the answer. So what if I put step here, if I put step 2 here, then it will increment 2 times. Okay, here it's only incrementing once, but if I put step as 2, it will increment 2 times. It will increment 2 times like this. I'll try to explain this using a program, then we'll understand it in a better way. Now let's A is equal to, let's take a different or we can assume computer, and this is string. Let's try to print the type. The type of this string is class string. I'll try to print the length, len of G. I'll get the length here, length is 16. Let's try to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm also counting the space here. 10, 11, 12, 13, 14, 15, 16. So totally we have 16 characters inside this one. That's the reason I got the output 16 whenever I printed the length of this string. And now let's try to use the indexing concept here. So I want to print g of 0. What I'll get here? G of 0, I'll get C here. I got C. Let's try to print 2. For 2, what I'll get? C is 0, 0, O is 1, M is 2. So I'll get M here. So let's try to print minus, let's try to use the negative indexing. So what's the -1 here? E is the -1. So I'll get E because 0 to 1, the positive index starts from right to left. Sorry, left to right. From left to right, the positive index starts from left to right, but the negative indexing starts from right to left. So for E, I'll get like -1 is the index. For C, -2 is the index. -3 is the index for N. Now let's try to slice it. Print. First, we need to give the starting index. I'm going to give 2, and then I'll give, let's give 8 here, or let's give 10. Let's give 1. Okay, so for the step variable, if we don't give anything, then the default value of step is 1. Okay, even though I don't give anything here, then the default value is 1. But if we want the step to be 2, then we need to mention it. But if I don't mention anything, then step value is by default 1. Now let's try to put it inside the square brackets. Now let's print it. So we can see here from 2 until 9 we got it. Now let's try to use step here. Print G. So where is my pen here? So here this computer science is stored inside the memory like this. COMPUTER. We have a space here. After that SIENCE 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So -1, -2, -3, so on. Okay. Negative indexing starts from right to left, and the positive indexing starts from left to right. So now whenever I printed this one, what is -1? I'll get E here. That's what we got here. First I'm printing the type. I got string here. Then I'm trying to print length. I got 16 here because the length of the string is 16. 0 to 15, it's 16. Then I try to slice it from this 2, okay, from this 2 until 9, because I already told you whenever I put the stop, then the slicing happens from the start index to stop -1 index. So stop is 10, then it will occur until 9. So that's what happened here. MP until S, we got the string here. MPU TR, we got a space. We also got the space here. Then we got the S. So now when I put this step value as 2, what happens here? First this will print, and then this will print 2 times. Okay, we need to increment the pointer to 2 times. Okay, this will print, and that's it, because we don't have anything. Okay, we don't have C here because we are only mentioning until 10. So we don't have this one until this will get print. Okay, M U E, we got M, we got U, and I got E. So that's what I got. We got the output. So I hope you understood the concept of slicing using strings. This is how we'll try to slice the string. Interesting. Okay. So now we will discuss the last topic in this lecture, typecasting. So typecasting is a concept. We all know what is meant by type. Okay, we discussed this a lot of times. So the concept of typecasting is nothing but, so to convert from one type to another type. So to convert from one type to another type. So we can convert from, we can convert one type value into the another type. This conversion is called typecasting or type conversion. The following are the various inbuilt functions for typecasting. So this integer function, this is used to convert any other type to integer type. This is used to convert to float type. This is used to convert to complex type. This is used to convert to Boolean type. This is used to convert to string type. So integer type, we can use this function to convert values from other types to integer type. We can convert from any type to integer except complex type. Okay, if we want to convert string type to integer type, compulsory string should be contain the integer value should be specified in the base 10. Okay, look here, if I want to convert any value, like if I want to convert 2.3, then I can do that. I can convert it into the integer format. If I want to convert, any other value like Boolean value, I can convert it into the int. It's 1. Will you 2.0? Let's look at it using an example. A is equal to 1. Let's try to convert it into the integer format. 1.4. We'll only get 1. Okay, we'll only get the part which is to the left of the decimal point. Then let's try to convert it. Bool 1 is equal to, let's try to convert it to the integer type. Bool 1, I'll get 1 here because true is internally represented as 1. We already know that true is represented as 1 internally and false is represented as 0 internally. If I take false here, then I'll get 0 here. Okay, and as we already saw here, oh, we can convert from any type to integer type except complex type, because we can't convert complex type into integer type. We can convert string type to integer type. We can convert Boolean type to integer type. We can also convert float type to integer type, but we can't convert complex type to integer type. If you want to convert the string type to integer type, then I'll show you the condition. Okay, so let's take string value here. If I want to convert the string value into integer type, then the string value should be in the integer form. Okay, this should be in the integer form. Int. If I try to convert it here, then I can convert this one. But what if I have like this? I can't convert it. I'll get an error. So the point is that if I want to convert the string value into integer type, the string value should be in the integer format. Okay, in this integer, then only I can convert it. Okay, this 10,000 value is in the string format because we enclosed it with a double quote string. This is in the string format, but the value should be in the integer format. I cannot write a text, and I cannot convert text into integer format. If I want to convert the string to integer, then that value should be in the integer format, and it can be any number. Okay, it can be any number. We can convert it. Here I try to convert the 10,000. Then if I try to now, let's try to type of string value here. It's string, but if I try to print the string of this one, one, two, okay. So now when I try to convert the string type into integer type, the type is int here. So the two conditions are, First, we can't convert complex type into integer type. Then the next one is that if I want to convert string value into integer format, then the value should be in the integer format. It can't be in the string format. Okay. I already showed you that if it's in the string format, then we'll get an error. Okay. Then comes the float. Float. We can use float function to convert other type values to float type. Look at here. This is lowercase letter. Sorry, this is the lowercase letter. So if I try to convert the integer type, then it will come 10.0. Okay. If I try to convert 20, then it will get converted like 20.0. The point will be added, and the 0 will be added after the point. So if I can, just like we can't convert complex to integer type, we can't convert complex to float type too. So complex to integer is not possible. Complex to float is also not possible. It's not possible. If I try to convert true, we'll get 1.0. If I try to convert false, we'll get 0.0. We all know that true is internally represented as 1, false is internally represented as 0. When I try to convert bool value into integer, I got 1, but for float I got 1.0. Just like 10, we got 10.0. At the same time, for 1 we got 1.0. And we can't convert string type into the float type. We can convert string to integer. String to integer is possible. String to integer is possible, but what's the condition? The string value should be in the integer format. But string to float is not possible. String to float is not possible. So we can, these are the two conditions. Okay, we can convert any type value to float type except complex type that we already saw. Whenever we are trying to convert string to float type, compulsory string should be in integer or floating point literal, and it should only be specified in the base 10. So I already told you here, we can't convert string into float. Okay, like we can't convert, if you have any string value like this, we can't convert into float. But if I still want to convert string to float, then it should be either in the integer format and it should be in the float format. The same concept applies for the integer too. If I want to convert string type to integer, the string should contain integer value to the integer value. The string should be the integer value. And the same concept applies for float value too. If I want to convert string type to float, then compulsory the string should be either integral or float point literal. But I can't convert string to float. Okay, I can't convert like this. If I have string, if I have a string ABC here, then I can't convert it into the float point. I can't even convert it into the integer. But if I want to convert it, then I should either write it in the integer. I can either write it in the float format. Okay, then I can convert it to the string. And we have the complex function here. We can use complex function to convert other types to complex type. The same logic applies. I mean, you know, for the integer function, we can convert the other types into integer. For float, other types to float. The same concept applies for complex. If you want to convert other types into complex type, then we can use complex function. We have two forms for this complex function. The form one is that we can use this function to convert x into complex number with real part x and imaginary part 0. So for example, if I am going to convert 10 into complex number, then it will be converted like this: 10 plus 0j. That's what happening here, 10 plus 0j. If I want to convert 10.5, then it will get converted like this. Okay, 10.5 plus 0j. 0j. And if I'm trying to convert in the Boolean form, true, we know that true is internally represented as 1. I'll get 1 plus 0j. This is the form 1. I can just specify one number. Using that one number, it will get converted into the complex number. In the form 2, we can give both numbers. Okay, I can give the real part, I can also give the imaginary part. So I can give like this: complex 10 to, this will become the real part, this will become the imaginary part. So it will, we'll get the output like this. If I take complex 1000 to, what we'll get, 1000 plus 2j. So if I try to convert true plus false, true is nothing but 1, false is nothing but 0, so 1 plus 0j. And the last method is string method. Okay, we also have boolean method too. Boolean, this is not the last, we also have the boolean function. So this is a string function. We can use this method to convert other type values to string type. So if I'm going to mention 10 here, it will get converted to string like this. If I mention complex number, it will get converted into the complex number. And if I use str 2.3, we'll see that. So first a is equal to 10. Print, we'll try to convert it into the, we'll try to convert 10 into string format. And then we'll try to convert 10 plus 10 plus 20. C is equal to 10 plus 20j. Let's convert this one here, str of C. So now we got strings here. What happened? Type of string. One two. Okay, this was not closed here. Why is it not closed? Okay, I'm trying to close it. Yeah. So you can see here, whenever I'm trying to convert this decimal into string format, like first we defined an integer object. Here we defined a complex object. And then when I try to convert it, when I try to convert it into string, we'll get these, it will be shown in the string type. Let's try to define a float value here. 5.6 print type of float value. We need to convert it into string format here. Incomplete input 1 2 3. Okay, I need to put another one here. So this one is also into string format. So we converted the integer to string, we converted complex to string, we converted floating point to string. So what we will get here after we'll get 2.3. So next we have another function, boolean function. We can use this function to convert other type values to boolean type. This is very easy. Okay, for boolean function, if we have 0, then we'll get false. If we have anything other than 0, then we'll get true. If I have 222, then I'll get true. If I have 1, I'll get true. If I have anything else, I'll get true. And the empty string is nothing but false. Okay, so whatever we have, if I have 10, I'll get true. If I like other than 0, whatever I put here, I'll get true. If I put 0, I'll get false. That's the basic idea of boolean function. We can use this function to convert other type values to boolean type. Please practice if you want, just practice, just try to define different type of variables, different type of objects using these data types, and then try to use all these functions and practice it. It will just take like 10 to 20 minutes to practice different type of examples, then you'll good to go. Okay, so thanks for joining this lecture. In the next lecture we will talk about the memory management, and we'll then start with the data types part 2, because we just discussed the fundamental data types in this lecture. We'll discuss the other data types in the upcoming lectures. Okay, thank you so much for joining. Have a nice day.